binuclear carbonyls are there. Mononuclear carbonyls means only one central atom is present. That means D block element, the central atom is having of that one nickel tetracarbonyl. So nickel is a central atom, and around the central atom 4 carbonyl groups are surrounded. It is a coordination number is a 4. We are having of the tetrahedral structure, nickel tetracarbonyl, like that ferrous hexacarbonyl, like that we are having of that one. Bionuclear carbonyls also two central atoms are there. The central atoms are 2 are called as a bionuclear carbonyls. Like that you are give the example that biocarbonyls will be finished. Next is the silicates. Silicates means the carbon is having of the different type of silicates are there. Pyrosilicates is there, chain silicates is there, cyclic silicates is there, sheet-like silicates are there, and zeolites. 5 categories of the silicates are there. Just you draw the silicate structures. Why? Because it is the units of the silica tetraoxide units. Number of units are joint molecule, you say the forming of that silicates are formed. Next is the silicones. Silicones are nothing but alkyl substituted halide groups, the silicon with present, those are called as a silicones. Okay, mainly silicones are used for the hot heat baths. It means high temperature. That it will be maintaining of high temperature. Silicons will be there, and greases, varnishes. In that door, the silicon will be used. Okay. Next is the third chapter. We have discussed with that is 58 group elements: nitrogen, phosphorus, arsenic, antimony, bismuth. These are the elements which are having of the nitrogen, phosphorus, arsenic, antimony, bismuth. Here nitrogen is a diatomic, phosphorus, arsenic, antimony are the tetraatomic in nature. Bismuth is anyhow you are having of the bismuth. We are present in that bismuth is a radioactive element. Okay. So that is very important of that one. With the what is the main importance of the nitrogen? Nitrogen is forming of the oxides. The oxides are very peculiar oxides. Why? Because plenty of the nitrogen, means most abundant gas in the atmosphere is nitrogen. This nitrogen and oxygen is the second position of in the atmosphere, but they do not react under normal condition. Under drastic condition means during the thunderstorms, nitrogen is reacted with the oxygen formation of varieties of the oxides. That is called as NOx types. NOx means NO, N2O, N2O3, N2O4, N2O5. Like that the oxides of the nitrogens are formed. In this, N2O is called as a nitric acid is called as a laughing gas, NO nitrous oxide, and N2O3 nitrogen trioxide, nitrogen tetroxide, nitrogen pentoxide. These are the oxides are present. When these oxides are dissolved in the rainwater, we are getting of acid rain. So that is the formation of the acid rain in the earlier stage of that one. Why? Because most of the atmosphere is accumulated of oxides of the nitrogens are today because of your burning of the fuel. Unburned fuel, not only that one, chlorofluorocarbons are emitting to the atmosphere, there is a creating the acid rains. This will be happen due to of this reason. Okay. Next is the oxy acids of the nitrogen. What are the oxy acids? We are having of the 4 categories of hypernitrous acid, nitric acid, like that we are having of that one. Next is the preparation of the nitric acid by means of Ostwald process. Ostwald process nitric acid is very important. That is a 10 marks question. Next is oxy acids of the phosphorus. Phosphorus oxy acids are 6 are there. Phosphoric acid, like that you are using of that one. Next is preparation of the superphosphate. That means calcium hydrogen phosphate plus calcium sulfate. This combination is called as superphosphate. We are preparing with the help of the rock phosphate. When rock phosphate is crushed into fine powder, that means rock phosphate is also called as a borash. Crushed into fine powder and mixed with the concentrated sulfuric acid and keep in the door place at about the 2-3 days. You are getting of the fermentation process. You are getting of the superphosphate. This superphosphate is a good manure for the agriculture sector. So farmers can use the superphosphate. Next is irisin, hydrozoic acid. Hydrogen means N2H4. The preparation will be there. Hydrozoic acid is N3H. Hydrozoic acid preparation. These are the 5th A group elements, important elements. Okay, this two both are discussed in the last class. Now today we are going to the black 2. Black 2 consisting of the 3 units again. That is the fourth unit is the alkynes, fifth unit is the benzene, and sixth unit is the arenes. Okay, these are the three chapters are present in the black 2. So adding of that one. Alkynes are there. Unit 5 is benzenes and unit 6 is arenes. This is the fifth chapter. The sixth chapter. This we have to discuss today, black 2. So the black 2 alkynes. What are the alkynes? So very unsaturated hydrocarbons consisting of the triple bond between the carbon and carbon. That means the alkyne functional group is triple bond is present. This is called as alkyne. It is very unsaturated hydrocarbon. Very unsaturated hydrocarbon consisting of a triple bond between the carbon and carbon, and it is a linear structure. Linear structure making of the bond angle is 180 degrees, undergoing of sp hybridization. This we are having of the idea regime means these are unsaturated hydrocarbons. It is a linear structure and the bond angle is 180 degrees and undergoing of sp hybridization, and general formula of these alkynes are CnH2n minus 2. This is the general formula of alkynes. So when you are observing the general formula of alkynes, if you are giving off minimum number of carbon atoms are 2 because of a triple bond is present this one. So n is equal to, keeping of n is equal to, regarding the first member in the alkyne series is C2H2. This is called as ethine. But common name it is called as acetylene. The common name is acetylene. That we are giving up that one. Okay, next C3 4. It is called as propyne. Ine is the, we are having out the primary suffix. This is ine is the primary suffix here there. So this is about the interaction of, this is a very unsaturated hydrocarbons. The functional group is triple bond between the carbon and carbon. Okay, linear structure, 180 degrees bond angle. The bond angle is 180 degrees. And sp hybridization, general formula is CnH2n minus 2. And the members of the first member of the in this alkyne series is ethine. Next is the propyne, like that, so on and so forth. Okay, this is about the alkynes. So this particularly introduction part of the alkynes. Okay. So now in this main important is the preparation of alkynes. How the alkynes are prepared? This is a essay type question. In this, alkynes are prepared. That means after so many methods, three methods are very important. Preparation of alkynes. First is industrial method. Already told in that second chapter, that is the carbides. The carbides is the ionic carbide. Calcium carbide on hydrolyze. When calcium carbide is hydrolyzed, you are getting of the calcium carbide is hydrolyzed. You are getting this two molecules of the hydrolysis. You are getting of alkynes. That means acetylene is prepared and calcium hydroxide is formed. Okay. If you see the street vendors, they are using of the arc welding purpose. One cylinder, there is a calcium carbide is there. It is a particularly calcium carbide is used as the artificial ripening of the fruits. They're keeping of the spraying of the powder or keeping of the this part of calcium carbide, the solid in the paper. They spread into that means it is a formation of ethylene gas. This ethylene gas is used as a ripening of the fruit. This industrial method preparation, but this calcium carbide is banned in our country. But they're illegally taken out that getting off that one. They are using as illegally for the ripening of the fruits. It's a very dangerous one. It is emitting of the ethylene gas. Is the industrial method. Next is second method is dehydrohalogenation. Dehydrohalogenation. The name itself, we are having the we are eliminating hydrogen as well as the halogens. Those are called as dehydrohalogenation. How this is nothing but the dihaloalkanes. We are using of the dihaloalkanes. See the structure. I can write the structure if it is 1,2-dichloroethane. When 1,2-dichloroethane is treated with the alkalic potassium hydroxide, excess amount of the alkalic potassium hydroxide, both the halogens as well as the hydrates, that is hydrogens are liberated. So dehydro, hydrogens as well as the halogens are replaced. Formation of 2 moles of Kx, that means Cl, KCl, and 2 moles of water will be liberated out. You are getting of a triple bond between the, this is ethylene is prepared. Okay, very simple method. This is also dehydrohalogenation. And third one is very important one, dehalogenation. Dehalogenation. This means only halogens will be eliminated out. Previously, we are eliminated hydrogen as well as halogens. This is called as a dehalogenation. Here, tetrabromoethane. I'm using of taking of the tetrabromoethane. See, this is a tetrabromoethane. Okay, very simple, easiest. In presence of zinc dust, this tetrabromoethane is, that means 4 bromines halogens will be eliminated out with the help of the zinc. That means we have formation of zinc bromide. ZnBr2. Okay, 2 moles of ZnBr2. That is getting off ethylene gas. See, these are the 3 methods which are useful for the preparation of alkynes. This is enough for your examination point of view. First is the industrial method. Next is the dehydrohalogenation. Next is the dehalogenation. Next, coming to the properties. When you see the properties of this one, this ethylene gas is a colorless gas, and this particularly ethylene is in garlic smell. The smell is garlic, highly inflammable and unstable also. So main physical properties of this but is the colorless gas and garlic smell, highly inflammable one. That's why you are using that this particular ethylene is arc welding purpose. So gas welding, you never called as a gas welding. That is a ethylene gas is used. Now coming to the chemical properties. The chemical properties also very important. Why? Because the question will be sometimes not only the preparation, they'll ask the write the preparation and also chemical properties of the alkynes combined with the 10 marks question. So 3 are the preparation, next 3 or 4 we are get write the preparation, then the chemical properties, then you will getting up the 10 marks in this question. Okay. Now you see the properties. Okay, now I'm getting the properties of alkynes. First is addition property. So first addition, that means it is called as a reduction process. When the alkynes reduce in presence of hydrogen, that means it will be addition, or you can call as a reduction process. And the alkyne means CN H2N minus 2, adding of hydrogen in presence of nickel catalyst, getting of CN H2N. That means this is the alkynes. You get prepared alkene. Then again we are adding of hydrogen in presence of nickel catalyst. We are getting of CnH2n plus 2. It is alkane. It is a general property of alkynes is addition reaction or reduction reaction. This is a very important one we have to use. Okay. Next is addition of halogens. Addition of halogens. Simple. When we are thinking of ethylene gas, that will be your halogen will be added in presence of ferric chloride. That means any halogens, or you can take the bromine in presence of ferric chloride. Formation of simple tetrabromo ethane is formed. Excess amount of that one. So simple, when you are using in the preparation properties, same manner tetrabromo ethane is prepared. Okay, this is called as tetrabromo ethane. Okay. This is a addition of halogens. Addition of hydrogen halides also there. Addition of hydrogen halides means HX, hydrogen halides means it only X that way. Okay. So addition of hydrogen halides means when we are taking of ethylene, we are using of HBr. Okay. When you are using of HBr, so directly formation of bromine will be attacked. It means 1,1-dibromo ethane. 1,1-dibromo ethane is formed. 1,1-dibromo ethane. Next is one more very important one is hydrated one. When ethylene is hydrated in presence of concentrated sulfuric acid containing mercury sulfate. This property is very important. Sometimes it is asking for the separate 5 marks bit. Addition, that means we are using of addition of water. It is a very important one. Nothing but when ethylene gas is hydrated in presence of concentrated sulfuric acid. This concentrated sulfuric acid is containing mercuric sulfate. Barley reacted with the intermediate product is formed. Then intermediate product is again the oxidized. They are getting of the acetaldehyde. Formation of acetaldehyde is formed. This is very important one. Okay, they ask separately for the 5 marks question. When the ethylene is hydrolyzed, ethylene is hydrolyzed, you are getting of acetaldehyde. Okay. Next, fifth property, oxidation. This is also sometimes asking this question. The question is how to prepare oxalic acid from ethylene. The question is nothing but the oxidation. So oxidation means when the ethylene gas is oxidized, means in presence of oxygen, nothing but when presence of oxygen, there is an acid oxygen, formation of oxalic acid. This is the oxalic acid is formed. COOH, COOH. That is nothing but the formula is H2C2O2. This is a formula. This oxalic acid is formed. It is also very important. Oxalic acid is formed. Okay. This undergoing the oxidation process, we are getting of the oxalic acid. Further oxidized, this particular oxalic acid is converted into carbon dioxide and water only. Simple. Okay. These are the very important one. Suppose if there is a one more example also there, when the hydrogen cyanide, ethylene is reacted with hydrogen cyanide, your formation of acrylonitrile will also form. That means H double bond to 2, there is a HCl will be formation. These are the enough for the properties. Okay. First is the common property, that is the addition or reduction process. Next is addition of halogens, addition of hydrogen halides, addition of water. Next is the oxidation. These are the properties which are using of. Suppose in the examiners they have separate also for the 10 marks bit. Why? Because each 5 steps are there. Each reaction carries the 2 marks. We're getting up the 10 marks for that. Okay. These are the properties of ethylene. Only 2 more members. No one is interested in the online classes. Suppose here, these are the important topics. Why? Because in the second sem, easy to getting of the more marks. Organic part is more getting of the more marks. Why? Because all are equations, just like the mathematics steps. So we won't get the marks also. This is no theory part. Everything is reactions are there. So reactions, when you are writing of the properly reactions, you will get the full out of 10 marks means you will get the 10 marks also. So that much easy of the organic part. Just only the thing is understand the organic part and practice it. You will get the good marks. So after the preparation and the properties, we have to learn. And one more question is also asking, what are the uses of the ethylene gas? Already I told that ethylene gas is oxyacetylene is used as a flammable. It is a highly flammable one. This is used as a gas welding or cutting of the any one. That means you can cut the iron pieces by means of the gas welding. That means that particular arc welding. Okay. So the oxyacetylene gas is used for that purpose. And also I told that this is particularly garlic smell is there. So, and also this particular ethylene gas is used for the artificial ripening of the fruits and vegetables. And also it is used for the dyes, perfumes, plastic industry and rubber industries. This ethylene gas is used in the dyes, perfumes, plastic and the rubber industry. These are the uses. It is also asked what are the uses of ethylene gas. First, ethylene gas is used as the welding purpose and cutting purpose. Okay, that oxyacetylene is used with that one. Next is ethylene gas is used as a artificial ripening of fruits and vegetables. Next is it is used for the preparation of the dyes, perfumes, plastic industry and the rubber industry. These are the uses of ethylene gas. Okay, and next one more question is every time asking the question is acidity of alkynes. Explain the acidity of alkynes. Here, when you compare the hydrocarbons, alkanes, alkenes, and alkynes, alkanes are less acidic than alkenes than alkynes. That means alkynes are more acidic than the alkenes and alkynes. Why? What is the reason behind this one? Means when you compare in the acidic character of the hydrocarbons, I will write the comparison between the three hydrocarbons, alkenes, alkenes, and alkynes. We'll show that one. So when you copy this one, now acidic character of alkynes. Let's see in this chapter we are running off. These are the questions. First is the preparation, next is the properties, next is the uses, next is the acidic character of alkynes. These four questions are every time repeating the questions. Acidity of alkynes. I am writing off first alkanes, alkenes, and alkynes. And comparison with this one. We are taking off the general formula Cn H2n plus 2. This is a general formula of alkynes. Alkanes. This is a general formula of Cn H2n. This is a general formula of Cn H2n minus 2. Okay. Now coming to the hybridization. This alkanes undergoing of sp3 hybridization. These alkanes are undergoing of sp2 hybridization. These alkanes are undergoing of sp hybridization. Now, in this sp3 hybridization, what do you say? One spherical shaped s orbital, three dumbbell shaped p orbital, combined together, hybridized together, formation of 4sp3 hybrid orbitals. Those are arranged in the tetrahedral manner. Making of the bond angle is 109 degrees 28 minutes. Okay. Here, one spherical shaped s orbital, two dumbbell shaped p orbital combined together are arranged as a trigonal pyramidal and making of the bond angle is 120 degrees. Here, one spherical shaped s orbital, one dumbbell shaped p orbital combined together formation of a linear structure making of the bond angle is 180 degrees. It means bond angle is 109 degrees 28 minutes. Here this is 120 degrees. Here it is 128 degrees. Now coming to the in this S character. How much S% is present means S is 1, P is the 3. 1 plus 4 is equal 100%. Means S character is 25% of the S character and 75% of the P character is there in the sp3 hybridization. Coming to the sp2 hybridization, the S character is only 33%. Here S character is 50% of the S character is there, 50% of the P character is there in the sp hybridization. When you are seeing of the S character in these cases, sp3 means alkane is having the S character is 25% only. Alkenes having the 33%, but alkynes having the 50% of S character. Gradual increasing of the S character showing of the acidity of the alkynes. The reason, main important reason is the gradual increasing from alkanes to alkyne. The S character is increases. Due to the S character is increasing, that is the mobiling of the electrons are very easily. That's why it is loses the electron. So alkynes are act as a acidic character. That's it. Due to the 50% of the character of the S character carbon, the electrons are compared to the very close to each other carbon atom. So these hydrogen atoms are mobile and lose the photons. Hence, alkynes are acidic in nature. When you say you have to write this much is enough for that one acidic character. Only the thing is one word, adding of the word is gradual increasing of S character in the alkynes. So it loses easily electrons. That means the hydrogen is very close to the carbon atom. That's why losing of the electrons. If any compound is losing the electron easily means that shows that it will be exhibit the acidic character. So hence alkynes are acidic in nature. Okay, this is about the one more question of in the alkynes. Now coming to the next chapter, this is only the fourth chapter. It is finished. And fifth chapter is benzenes. So what is benzene? How we are getting of this benzene? Actually, in the 1825, Faraday discovered benzene in the whale oil destructive distillation. So the story of the benzene is in 1825, Faraday is discovered by the destructive distillation of whale oil. Whales are present in the ocean. When the whale is the liver or whatever the bodies are destructive distillation, the oil is coming, that is called as a benzene, the first discovered by the Faraday. In 1834, Mitscherlich discovered the formula of benzene. Benzene formula is C6H6. Mitscherlich discovered the formula by means of molecular weight. So the molecular weight of the benzene, we are having of the 78 molecular weight is there. So the 78 on the basis of the molecular weight, Mitscherlich found that the benzene structure, that means the benzene formula is C6H6. Okay. So the story of this one is seeing of this one. Faraday is discovered the benzene in the first in the whale oil. When the whale is destructive distillation, we are getting of that oil is consistent of the benzene. The formula is discovered by the Mitscherlich by means of molecular weight. It's molecular weight. Now, seeing of this molecular weight, when you are taking of the hydrocarbons, CnH2n minus 2, it is called as the alkynes. When the same formula, if you take CnH2n minus 6, it is called as a benzene. Okay. When you are saying of the benzene, formula, see similar to this one. When you comparison between this one, alkyne formula is CnH2n minus 2. Okay. That also CnH2n minus 6. We are getting of n is equal to 6 means we are getting of C6H6. If n is equal to 2 means S3. These are the comparison. So, alkynes is a very unsaturated hydrocarbon. Similar manner, benzene also unsaturated hydrocarbon only. Benzene also unsaturated hydrocarbon. If unsaturated hydrocarbons, they must undergo addition reaction. Just now you are doing addition reaction, addition of hydrogen, addition of halides, addition of hydrogen halide, addition of water. So many properties you are learned in the alkyne series. Similar manner, benzene also, by means of seeing of it is unsaturated, they must undergo the addition reaction. But unfortunately, benzene does not undergoing addition reactions. By seeing the formula is it is unsaturated, but does not undergoing an addition reaction. This benzene is undergoing of substitution reaction. Who are undergoing substitution reaction? Actually, saturated hydrocarbon means alkanes undergoing the substitution reaction. Similar manner, alkanes type, this particular benzene is undergoing of substitution reaction. So, according to the molecular formula, it is unsaturated compound. They can undergo addition reaction, but benzene does not undergoing addition reaction. Instead of that one, they are undergoing substitution reaction. This property is called as aromatic property. Hence, benzene is act as aromatic character. Hence, benzene is act as an aromatic. Aroma means fragment smell. It's a fragment. Very good smell fragments. So lily flowers we are seeing of jasmine. These are the flowers as we get that is a property, a smell. Similar like the benzene also a fragment smell. Aroma that will be forming. This is a main important of the aromatic character. So in the examination, what is aromatic character? Explain with example. Aromatic character is nothing but the formula is just like the unsaturated hydrocarbon, but they cannot undergoing addition reaction. They can undergoing substitution reaction. Such phenomenon is called as aromatic character. Example, benzene is, the formula is CnH2n minus 6. It is an unsaturated hydrocarbon, but they cannot undergoing addition reaction. It can undergoing of substitution reaction. Hence, benzene is aromatic benzene, aromatic character. That is important. And also, it is explained by means of Huckel's rule. Huckel rule, what is that Huckel rule? So, it is explained by the Huckel rule. This is also important in the examination point of view. Huckel's rule is nothing but 4n plus 2 pi electron system. 4n plus 2 pi electron system is called as electrolysis. See, any compound, the n is equal integer you are getting, n is equal to 1, 2, 3, like that, any integers are getting, those compounds are called as aromatic. Let us see this particular 4n plus 2 pi electrons. This means Huckel's rule. How many number of electrons are present in the benzene? 6 pi electrons are present. 6 pi electrons are present in the benzene. This is for benzene. So, if you are using a 4n pi electrons is equal 6 minus 2 pi electrons. Means 4n pi electrons is equal 4 pi electrons. 4 that means n is equal to 1. Okay, n is equal to 1 means integer. It is a aromatic. So hence benzene is aromatic. Aromaticity. It's showing off. That means we are proving with the help of aromatic character, with the help of the not only the chemical reaction, with the help of the Ackel's rules also, it is showing of aromatic character. Why? Because 4n plus 2 pi electron rule is obeying of the benzene. Just like the naphthalene, anthracene, these are all our aromatic characters we are using of. So this is about the benzene main important one. So in here, main the induction part of consisting of the what is aromaticity, what is Uckel's rule. We are clearly given as this aromaticity and Uckel's rule. So aromaticity is nothing but formula reveals as a unsaturated, but they now do not undergoing addition reaction. They can undergoing of substitution reaction. Such mechanism, such phenomenon is called as aromatic character. Benzene is undergoing of aromatic character. Uckel's rule what? 4n plus 2 pi electron system. If n integer n is equal to, if you are getting a 1, 2, 3, those compounds behave as a aromaticity. So in the benzene, number of pi electrons are 6 pi electrons are present. Why? Because it's alternative double and single bonds are there. So there are 6 electrons are 6 pi electrons are delocalized one in the rings itself. So you're getting of n is equal to 1. Hence it is a benzene is a aromatic character. That's it. Okay. Now coming to the structure. When you observe the structure of the benzene, by seeing of the molecular formula, it is a very unsaturated hydrocarbon. If it is an unsaturated hydrocarbon, structure of the benzene, by seeing of the C6, it is a very unsaturated. This is the molecular formula is CnH2n minus 6. But when seeing of this one, if you are, it is a undergoing saturated. That means substitution reaction means, if it is substitution means the minimally consisting of C6H14 electrons will be there. Then only the bond formation is there. Alkenes, it is a hexane, but 8 hydrogens are less in the benzene ring structure. If it is a saturated means single bonds are there. 6 carbon atoms are single bonds. Okay. If you are having of this one, requiring of 14 hydrogens are required. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 required. But here we are having of only 6, 8 hydrogens are deficient. That means there may be a double bond or triple bond is present. So many scientists are find out that means they worked on the structure of the benzene. No one succeeded. So many years, almost all 20 to 25 years, they try to represent the structure of the benzene. But ultimately, lastly, that means so many means Dewar is tried, Neil Armstrong is tried, and also they tried so many others. Lastly, concluded in the 1865. See the years. 1825, Faraday is discovered the benzene. 1834, formula is obtained. In 1865, structure is obtained. See this gap of that almost 30 years. 30 years of so many number of scientists are worked because of a peculiar formula is there. How can you write the structure? You don't know. But succeeded by the Kepler in 1865. That's why today you are using of Kepler structure. Almost all. It is also replica of Dewar. Dewar also given some just nearer the structure of that one. That's why it is called as Dewar Kepler structure also. It is nothing but hexagonal ring structure. How the ring structure will be present means, if you see the ring structure, this is alternative single bond, alternative double bond. That means here the carbon and hydrogen is present. Here the carbon, there is a hydrogen. Here the carbon, there is a hydrogen. Here the carbon, there is a hydrogen. So this is formalizing of the hexagonal ring structure of the benzene. Structure of the benzene is very important in the examination point of view. It is asking for the 10 marks bit structure of the benzene. So many scientists are given different structures. Some person is given as a double bond, some person is given as a triple bond, some person is given as a both double bond and triple bond. It is not concluded lastly, but some important is given as a D verb because of the resonance energy. By means of resonance energy, benzene is possessing the 36 kilocalories of resonance energy is there. Why? Because the benzene is undergoing of 3 moles of hydrogen. They are forming hexane structure. 3 moles of chlorine, formation of benzene hexachloride. 3 moles of like that, they are undergoing of the chlorination and hydration. They are undergoing of addition reaction. So that the benzene may be having of the like that structure. But ultimately, when you giving up one bond is broken out that one. That means you are breaking of one bond. It requiring of 28.4 kilocalories of energy is required. 28.4 calories of energy is required. When you 3 bonds are there, when you are breaking, that means breaking of the 3 bonds, it requiring of almost all 28.4 into 3 means how much you are getting of the 78 something will be there. So the difference actually experimentally found that the benzene resonance structure is 36 kilocalories. So resonance energy of benzene is 36 kilocalories per mole. This is a resonance energy. Due to of the resonance energy, Kepler and Dewar is found as a hexagonal ring structure, but actually is found as a Kepler a ring structure. It is a nothing but it is a dream of that one. Just he's going on the train, he's got the dream that will be snake is dancing. While the dancing of the snake, the tail is coming to the near to the mouth. So immediately wake up the calculator and draw the structure that will be concluded. Today you are using the benzene structure is hexagonal ring structure. It is consisting of alternative double bond and single bond is present. There is an alternative double bond. That means these 3 double bonds are delocalized. Delocalized means again you are getting of the similar structure of resonance hybrid. This is a then you taking off here the bond is there, here the bond is. Both are similar. That's why we are using in ultimately this structure will be a resonance hybrid. That means these are the electrons delocalized for every bond. Delocalizing of every bond, getting off that one. We are showing of this resonance hybrid is getting. So the 3 you have famous structures we are getting. This structure is available, this structure is available, and ultimately you are getting off this structure, this resonance hybrid. 6 pi electrons are delocalizing in this case. So that we are getting of the resonance energy is 36 calories. Okay, this is about the structure of the benzene. So in your examination, you must write the structure of benzene is very important. Then you go to the here main important is the interaction and structure of benzene. What are the resonance hybrid? What is the aromatic character? What is Kepler structure? That means what is the Huckel's rule and what is resonance hybrid? Okay, this is about the 5th chapter of the benzene interaction part. Next, coming to the 6th chapter. I hope you will give in this main important is the long question is structure of benzene. You have to write the so many number of scientists who obtain the structure, who draw the structures like the double bond, triple bonds, and Dewar structure, Armstrong structures. Those are having of the that is, and ultimately concluded as Kepler with the help of the Dewars, and as they are hexagonal ring structure, they are given as a 3 structures: resonance structures and hybrid. That means resonance structure means resonance 2 resonance has formed. If any compound is having of the resonance structures, those compound is a stable compound. Number of resonance structures are more, the compound resonance structures are more means it's a more stable. Here benzene is having of two resonance structures. This is called as a resonance hybrid. The last one is a resonance hybrid is getting. So this is about the resonance structure of that particular, and the resonance energy is the 36 kilocalories. Okay, we'll start the next chapter, that is arenes. If you are completing arene means black, second also you finish. This black completely you are carrying of the according to examination point of view 40 also 40 marks. So 6th chapter, that is arenes. So arenes are benzene and substituted benzenes. Benzene and substituted benzenes are called as arenes. Here benzene undergoing of electrophilic substitution reactions like nitration, halogenation, sulfonation, and Friedel-Crafts reaction. Those are called as arenes. So benzene and substituted benzenes are called as arenes. These are called arenes. Okay, friends, this is it. So this benzene is undergoes electrophilic substitution reaction. Electrophilic substitution reaction. I'm using of general reaction. If you observe the general reaction, you can doing of nitration, halogenation, sulfonation, anything. So every one is 10 marks question. Nitration of electrophilic substitution reaction benzene with nitration, 10 marks question. Electrophilic substitution reaction on benzene halogenation, 10 marks. Electrophilic substitution reaction sulfonation, 10 marks. General reaction, 10 marks. See, any can ask in the examination. That means here we are having a 1, 2, 3, 4 essay type questions are there in the electrophilic substitution reaction of benzene. Okay, what is electrophilic substitution reaction? I will show the electrophile. Here, maybe electrophile. I'm using of the electrophiles are electrophile is nothing but E plus. This is general electrophilic reaction. General electrophilic substitution reaction. Okay, so this electrophile maybe it is act as a Lewis acid. That means it may be a NO2 plus X minus SO3H also. These electrophiles, that means we are having of the these are the electrophiles which act as that one. Now we see the benzene electrophilic substitution reaction, how they are considered. If you practice this electrophilic substitution reaction, remaining nitration, halogenation, sulfonation is very easy. So here the electrophile is attacked. This is a fast reaction. This electrophile will be attacked on this electrophile will be at ortho position. At ortho position, this is the formation of that one. This is called as a pi complex. This pi complex slowly resonance will be taking place. That means alternative double bond and triple bond that will be broken out. Here the first, the bond is broken out here on this case. So if the bond is broken means we are getting off the immediately the electrophile will be attacked on that one. And also sorry, here the electrophile will here the attacking, you are getting off the bond is broken. The formation of a sigma complex will be a pi complex converted into a sigma complex. This will be formation. So here the place that will be there. Here the bond is formed here. That means here this bond is broken out. So that we are getting off attacking of the electrophile will be attacked on this one. Next case, this bond is broken out. So bond is formed here. This bond is broken out means you are getting off the a plus here. A bond is formed here. This will be converted to here like that. Okay. So again here there is an electrophile is there. Again this one. This bond is broken out. Okay. The formation of here say this bond is coming to here. There is a plus mark, electrophile and hydrogen. Okay. These three are there. Next, this formation, the formation of the a sigma complex means electrophile will be here. All are identical bonds. Here the bond is there, here a bond is there. Now the this is the attack done, this is an inverted formation. There is an electrophile is there. So this is called as a sigma complex. A sigma complex is formed. This sigma complex means a delocalized pi electrons will be converted into like that. Electrophile will be there. Okay. So this electrophile will be present under delocalized pi electrons. We are getting this sigma complex. Just you have to practice this step. This is a general electrophilic substitution reaction. First benzene ring, electrophiles like that. These are the electrophiles. You are taking up general reaction means E only you are taking. This will be attacked on the ortho position. This is a meta position. This is a para position. Ortho, meta, para positions. Here the electrophile will be attacked on the ortho position. So the slow reaction will be takes place. Why? Because resonance structures will be possible. So here the first bond is broken out. When the electrophile is attacking on the ortho position means this double bond will be broken out and formation of a plus, that means here formation electrophile. Next again this bond is broken out, here the plus is formed. Again this bond is broken out, here plus is formed here. So again this hydrogen proton is eliminated out, formation of one more resonance structure. This resonance structure, this is see that one. Here the electrophile is attacked on the ortho position. Okay, this is called as general electrophilic substitution reaction. Suppose instead of E plus, if I am taking off NO2, instead of E plus, I am taking off NO2 plus. Similar manner, you take simply on the E, you can substitute NO2 plus. On the E, you are getting off NO2 plus, NO2, 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 NO2. This is nothing but nitrobenzene. Preparation of nitrobenzene with the electrophilic substitution reaction on nitration. This is called as a nitration. This is a 10 marks. Previously, electrophilic reaction, 10 marks. General reaction. Nitration means you have to take only the mechanism in this HNO3 plus sulfuric acid. Reacted. Formation of, you are getting of nitronium ion NO2 plus, hydronium ion HO3 plus, and HS4 minus. This is a mechanism. In this NO2 is taken as a electrophile. That's it. Similar manner, halogenation. Halogenation means ferric chloride is reacted with the chlorine. ferric chloride reacted with the chlorine, we are getting of the chlorine Cl minus FeCl4 minus. Next, sulfuric acid H2SO4 on hydrolyzed, we are getting of SO3H electrophile. Like that, we are giving of the any step, just instead of here electrophile, we are taking of that one and the substituted on E place, you can substitute NO2 or X minus or SO3 reaction. Same steps are involved. So that's why please concentrate on the general electronics. There is a general electrophilic substitution reaction, that is E place. Here E place, so that you can get in guys the E electrophile. Electrophile be maybe NO2 place or X minus or SO3H that will be formed. So this is a nitration mechanism. You are getting of NO2. Second is halogenation. This I am taking of the electrophile here. Halogenation, what happened? Chlorine, Cl, you are getting of the ferric chloride. So Cl minus FeCl4, a byproduct is formed. FeCl4, this is a byproduct is getting up. Okay. Simple sulfonation, only sulfonation. Here simply H2SO4. Two molecules of H2SO4 is reacted each other, formation of SO3 minus and hydronium ion and also HS4 minus. That will be happen. Okay. So sulfur SO3 minus, you can act as a SO3. Here, if you take hydronium ion, SO3H means this is a SO3 minus, like that. Just substitute, these are the, we are getting of the general mechanism. Okay. So by this third unit also, second block also completed. Today we are covered 3 units. Alkynes, benzenes, arenes. 3 units, very, very important in your examination point of view. Compulsory 20 marks. Not only the compulsory, 40 marks also coming from these 3 chapters. 40 marks. So please concentrate on the block 2. It is a very important one. You are getting of the good marks. Okay. So already time up. It is almost all more than 7-8 minutes are over according to our scheduled time. So today you are leaving. Next class we are discussing about the block 4. Right.